So now we're going to get into some algebra, and that's going to be coming from the use of variables. So variables let us use an unknown that we don't know what it is, or if we want to plug in different values for it, but lets us set up this whole relationship around something that's unknown. And that's kind of the power of algebra, is to define a relationship where we don't know what one of the quantities is. So our unknown is going to be a variable, and the variable is going to be represented by a letter. And with that, we can use any letter that we want. Most typically, you're going to see X a lot. We use X a lot for our variable. Some letters that we would want to avoid using, we tend to want to avoid using E, I, and O. That is because E is actually a number in mathematics. It's Euler's number. It's something special that we can talk about when we do financial math or things that are exponential. Don't worry too much about that, but basically when we use variables, we don't really like to use E because it actually represents something in math. Same thing with I. I represents the square root of -1. It's an imaginary number, so we don't tend to like to use I either. And then O just looks like a 0, and we want to be careful of that. So you can use any letters you want, just be careful of those. Okay, so variable is a letter that's representing an unknown. A constant is just a number that stays the same. So just a number that we're working with is a constant. Let's talk about the difference between expressions and equations. So an expression has variables, constants, numbers, and operations. So all three of these are expressions here because it's just defining some relationship between different pieces, and that's it. What we can end up doing is simplifying expressions. So like this, where it's pretty complicated, we can take steps to make it look simpler. The other scenario is equations, and what we do is we solve equations. So like this 3x minus 2 equals 1, for this scenario, there's a single value for x that works here. It's going to be 1. Like we would want a 1 right there, and that balances this equation. So 3 times 1 is 3, minus 2 gives us a positive 1. So what we have is this solution that x needs to equal 1. So we have a solution up here where it was just an expression. There would be nothing we could do there. That expression would just stay the same. There's not enough information to do anything else. But with an equation, we suddenly have a possibility for values that would make the statement true. So that's what happens when we get to equations. Like with this one, it would be values for y and m that would balance this. For this one, it would be what value for x balances this. That gets us 54 out. And we'll have a whole section on how to solve equations and the steps for doing that. But these are two scenarios. If there's no equal sign, it's an expression, and that we can simplify. If there is an equal sign, it's an equation, which we can solve. So let's look at some scenarios where we can write out a variable expression given the information. So it costs $5 per adult, $3 per child to go to the movies. Write a variable expression. So what we could do is find out a way to represent what is the total cost, depending on number of adults, number of children. So that's our unknown here. We have some number of adults that are going to the movies, and we have some number of children that are going to the movies. And we don't know what that number is. Depending on the number of those, that'll adjust the cost. So this is what needs variables. We need some variable for the number of adults. We need a variable for the certain number of children. So let's go ahead and use capital A for adults, and let's use capital C for children. Now, $5 per adult, something we'll get used to is per typically comes through as multiplication. So we're going to go 5 times A, and then adding on the cost for children, 3 times C. So let's say there's one adult with 2 children. Let's try this out. One adult with 2 children. So their cost, they're going to have the $5 for one adult, $6 for the 2 children with $3 each. So a total of $11. So what we could do is when we make this variable expression, we could try it out by plugging in values. But that would be our variable expression. Okay, with this one, it costs $25 per day to rent a car plus 12 cents per mile. Write a variable expression. And let's go ahead and say that this is just for a single day. We can do both, actually. That might be a good exercise because there's a little missing context here. So if it's just one day, there's this flat fee of $25. So no matter what, we have the $25, but what's variable, what's changing, is the number of miles that we're traveling. So let's go ahead and set a variable M for the number of miles. So what this would look like is no matter what, we have that $25. That isn't changing based on anything. It's just for the one day, $25. And then we're going to add on 12 cents per mile. So we're going to have 0.12 times M. And with our different ways of writing multiplication, when you have a number and a variable next to each other, it implies that there's multiplication right there. So we can leave it just like that. So that works great if it's just a single day. Let's talk about what happens if it's multiple days, a multi-day trip. So we would still have the 12 cents per mile. That's actually going to stay the same, but what's going to change is the $25 per day. It isn't just a flat fee for one day. It's going to increase based on the number of days. So let's go ahead and use the variable D to represent the number of days. And what would happen is that now we'd have this multiplication here of $25 per day plus 0.12 per mile. And this equation would also work if it was just one day, but now this becomes like if we do 2 days or 3 days. But this is nice for something that we're going to be looking at later in the term with linear equations, where we have this kind of starting value and then increase from there. But if they're both variables, then we'd have that there. Okay. Kind of did this up above here, but let's talk about it in more detail about evaluating algebraic expressions. And this is where we're plugging in values. And when you plug in values, parentheses are going to be your best friend. I can't emphasize it enough. If I could spell it, parentheses. Don't always need them, but it's better to have them than to not have them is what's going to come down to. So let's say we want to evaluate 3x plus 2 when x is equal to 4. So what we're doing here is we're taking this algebraic expression, so this 3x plus 2, and what this really gives us is a framework to work with. We're taking 3 times whatever x is plus 2. And this is where my parentheses are coming in. My unknown is getting replaced by parentheses, and we're going to fill in the blank with whatever they're telling us to. So because they want x equal to 4, we're going to put 4 in there. And now because all the numbers have substituted for a variable, we can simplify. So 3 times 4 is 12, and then we're adding 2 on. So multiplication first, and then addition to get 14 out. So evaluating expressions is this substitution that we're doing where we're plugging in the values that are given into our expression. So let's look at a more complicated one. So we have 2 times x minus 1 plus 4 times y minus 2, and we're letting x equal 3 and y equal 5. So we're going to have x equals 3, y equals 5. So to get my structure going, we're going to have 2, and then this x minus 1, I'm going to put kind of bigger parentheses around it because I'm going to throw in parentheses for where x is. And then we're subtracting 1 plus 4 times, and then y minus 2. So that's my structure that this algebraic expression is telling me. And this first set of parentheses is going to relate to x. Second set of parentheses is going to relate to y. And so notice that we could just start choosing different values for x and y and plugging them in and simplifying. It's absolutely correct. Here they tell us what to use. So we want x equals 3, y equals 5. And then we're going to simplify. So we're going to take care of this 3 minus 1 first. And we could go ahead and do that 5 minus 2. So we have 2 times 3 minus 1 is 2. And then plus 4 times 5 minus 2 is 3. And then we can go ahead and simplify our multiplication here. So 2 times 2 is 4. And then we have this plus 4 times 3 is 12. Add them together, and that's 16. So evaluating algebraic expressions is where we plug in values into the relationship that's given to us. And again, just to emphasize, parentheses will help us so much. It is a little redundant with this one to use the parentheses, but especially when we get to negative numbers, it's going to be so helpful.